All right, good afternoon, everyone. Good afternoon, good evening, good morning, from wherever you are joining us from. Thank you all for joining us again today. Today is the third workshop. Last week we had Ayomide Aderele talking to us about building a strong methodology. And 2 weeks ago, we had Bidemi Beteji talking to us about laying the foundation and mastering literature review. And today, we have the incoming Dr. Meshach Aderele, who will be walking us through data analysis and interpretation. Again, my name is Philippe Adebayo, and I'll be your host for today. Without wasting too much of time, I would like to introduce our guest speaker for today. All right, our guest speaker for today, Meshach Aderele, is a data scientist and a PhD fellow at the Landcraft Aarhus University in Denmark, who is dedicated to utilizing modern technologies to address pressing environmental issues, which led to his founding of Tech Forest, which you can access through the link. His research primarily focused on the integration of artificial intelligence into process-based crop models to mitigate the environmental impacts of agriculture in Denmark. In addition to his research, Meshach actively teaches technology courses and offers consultancy services to organizations aiming to adapt tech-driven strategies as well as to newcomers eager to kickstart a tech-driven career. Without further ado, I would like to hand over to our guest speaker for today. But in the meantime, I want you to put in the chat, what do you look forward to learning today? Why are you here today? You can put it in the chat. All right, you can have the floor. Dr. Meshach.
Yeah. Hi, everyone. Can you hear me?
Yeah, I can hear you, but can somebody else confirm that they can hear our guest speaker for today?
Can you confirm if you can hear me?
Yes, I can.
All right,
Yeah,
thank
I
you.
can.
Okay,
Yes, we can.
great, great. Thank you very much. I think I'll proceed to share my screen now.
Yeah, you can share.
Yeah. I will, before I proceed, I want to ask if anybody on the call, if you've just put like a vote, if you've like conducted research before of any kind. If you've conducted research before, any kind of research, be um, any kind, any kind of research. Can I see in the charts, like even if you type yes or something to signal that you've done research before? I just want to know.
Yes, I have, sir.
Okay, interesting. Have you published before? Have you
Not yet.
published a paper before? Not yet. Okay. Do we have anyone on the call apart from Philip who has published a paper before in a journal or yeah, anyone? Okay, that's interesting. All right, but you can all see my screen, right? You can see my screen?
Yes, sir. Very well, sir.
Yes.
Okay, good, good. Okay, my name is Meshach, like I've been introduced, and professionally I'm a data scientist, and I'm currently doing my PhD at Landcraft, which is a staff Center for Sustainable Agriculture Futures. I'm here in the Department of Agroecology, in Denmark. And yeah, that's what I do. So I wake up with data and sleep with data. So because all that my PhD is about is using big data to build an artificial intelligence model that would advance how we do crop modeling and measure the environmental impacts of agriculture. So, so you can see, if you see PhD student there, here it is how we call PhD student or PhD fellow in Denmark. So that is Danish. Okay, yeah. So moving on, what is data analysis? And I'm sure everybody, in a way, understands generally what data analysis is, and it is very simple at the same time. It is just drawing insight from data using statistics and visualizing. That is how we can summarize it. Drawing insight from data using statistics and visualization. No matter the amount of code you write, no matter how good it is, how deep you are, the summary of everything you're doing, what we want to get in the end is insight. All right? What we want to get in the end is insight. If we don't get insight from whatever you've done, if it doesn't tell us something, then all the effort you've made is nothing in the end. That is the essence of data analysis. Every day, we are all unconsciously or subconsciously analyzing data in our mind every day. When you step out and you are going to, I will use like Nigeria as a case study. I know some of us may know Ibadan very well. Okay. Some of us may know Ibadan very well. If you're at Iwo Road and you want to go to UI, okay, there are several ways to get to UI from Iwo Road. You can take Uber, you can take the taxi, the Korokwe, like what they call it in Ibadan. You understand that kind of thing? You can decide to take a bike, or what do the best language they say, you fly bike. Okay. Now, when you are making that decision, you are making that decision with data. And how do you make that decision with data? What are the data you collect to make that decision? How much will it cost me if I take Uber, or I take bike, or I use the regular Korokwe? You collect data immediately in your mind. You are like, Korokwe should be around. It's been long that like I've had to go like to UI from Ibadan. But who can tell us what is the average cost if you want to go by taxi, the regular taxi in Ibadan, from Iwo Road to UI? If anybody knows Ibadan, maybe Philip will know, certainly. But it's been long.
That would be old data.
That will be old data, right? Okay, from your old data, how much do you think it costs on the average?
From where to where?
Iwo Road to UI.
Now I think it should be around 500 to 1,000, but then it should be around 100 to 200.
Exactly. So if it costs around 500 to 1,000, you are like, if I use Uber may charge me 6,000 to get there. Then if I fly bike, because bike will usually be expensive than the Korokwe, they may charge maybe 2,000 or 2,500. Now, in your mind, you immediately analyze the data. Is there a significant difference between all these three? You understand? So if there's significant difference between them, you now collect other kind of data, how quick you want to get to where you are going to. How quick you want to get to where you are going to. How much do you have in your pocket? What is the risk level that you can take? If you have high risk, what they call it, if you're attracted to things with high risk, you will want to fly bike from Iwo Road to UI. If you have low risk, I don't know the best terminology to use to it. Or let me use, if you are someone who doesn't like taking a lot of risk, you will surely want to use the Korokwe because it's a bit safer than flying the bike. Although in Ibadan, it may not be so different sometimes. Then if you're somebody who has money, doesn't like to take many risks or a lot of risk, you will go for maybe ordering a ride, like Uber, Taxify, if those things are available in a way. So every day you're analyzing data. What do you want to eat? You analyze data. Sometimes you want to eat, you say, what did I eat yesterday? And you gain insight from that to know what you want to eat. Sometimes it is not a question of what did I eat yesterday. It is a question of what do I have at home. I have 3 modules of rice. I have 2. So there's data everywhere. And as individuals, we are all analyzing data, whether we like it or not. And that is the angle I want you to think about it. So if you are working on research paper, as I've seen from the beginning where they talked about the literature review, Ayomide, my great friend, by the way, was talking about designing good methodology and every of those things. Now, for you to arrive at the data analysis, the big question that you want to ask yourself on the long run is, what do I really want to show? Or what do I really want to tell? That is that. Then it bridges the gap between raw data and actionable conclusions. Raw data and actionable conclusions. So when you analyze data very well, it helps us to make actionable conclusions. And we're going to see things like this when we practicalize one. Then another one is it is essential in both academic research and real world application. That is why you will see that data analysis has been trending. Data analysis has been trending. People will say, learn Power BI, learn Tableau, learn Python, learn R programming, learn this, learn Google Data Studio, learn Doc. All those things, they are there. It is becoming something that is very much trending. And the reason data analysis is trending this is because there's data everywhere. And for any business to make significant decisions that will move them in the right direction, they must analyze data and make decisions based on data. All right. So that is why it is trend. So data, it is essential to analyze data, even in our personal life. In our personal life. When you want to choose the school to go, you analyze the data. When you want to choose the university to go, all those kind of things. So data analysis, either you use it as a profession, you are subconsciously doing it. Subconsciously analyzing data. Now, what is the regular data analysis workflow? Number one is data collection or data generation. Data collection can be, you can use questionnaire to collect data. Some people use questionnaire to collect data. Some people, if it is about a system, for example, I work in agriculture and environmental science. So we have data about systems, agricultural systems. For example, data about crop yield, data about greenhouse gas emission. So we have people who work in for example, we all work in connected manner. I work as do data science task. I work with AI and all. We have engineers who build machines that we take to site to collect data using sensors. We have those who are doing experiments that will go to the field, they collect soil sample, they collect different kind of sample, they take it to the lab, they analyze it, and they provide data. So data collection or generation. Now, whatsoever you want to do, you want to analyze, whatsoever insight you want to have, if things go wrong here, everything will go wrong. Everything will go wrong. If something goes wrong here at the data collection or data generation stage, everything will go wrong. Everything. That is what they say. If the foundation is destroyed, what shall the righteous do? So the righteous in this case, we have to go and get data again. That's what the righteous will do. So if the data collection or data generation goes wrong, the righteous will have to go back and collect data. That is simple. That is simply how it is. So it is very important. So, and I see that people don't really care so much about what they do here. Everybody wants to use the big tool. They want to use the whatever. But if the way you have collected your data, if there's bias in the data you've collected right here, if there's bias in the data you've collected here, there's inaccurate recording, there are several things that is going wrong here. There's only so little that you can fix afterwards. Now, the next thing is data wrangling and cleaning. When we say we wrangle something, it is just like going into it, changing it, reorganizing it, making it clean. So the word data wrangling is just like what you do in your house on weekend. Some people wrangle their wardrobe. Okay, they wrangle their wardrobe and they are like, oh, let the jean come down, let the round neck go up, let the shoe go to this place. All right. I'm a very bad person when it comes to clothes wrangling. because I'm not really good at organizing these things. So if my wife is hearing me, she's going to be like, okay, I see what you did there. So for her, she's good at wrangling these things. She can organize this. She knows where the cup should be. She knows where this should be, and every of those things. So data wrangling is just like you go into the data, you are either changing something, removing something, adding something. So the process of data cleaning is still what you are doing in data wrangling, making the data ready for analysis. So the next thing after data wrangling and data cleaning is exploratory data analysis. So exploratory data analysis is very important. It's very important. So the exploratory data analysis is where you are asking, different kind of questions using the data. You just want to see what is the distribution of the data. Are there missing values? Several other things that you are trying to check in the data. Now, then the stage where people focus on a lot is the statistical modeling. And that is what people really emphasize on the call data analysis and everything, which will be a failure if all these three, you do them wrongly before you get to statistical modeling. Then the last thing is interpretation and inference. Interpretation and inference. So that is simply how the data analysis workflow look like. And the data analysis tools and libraries. So I want to ask anyone on the call who is ready to tell me, what do you think is the first tool in data analysis? The data analysis tool that comes to your mind. I need someone to respond. What do you think is the
Excel.
first data analysis? Microsoft Excel. Nice, interesting. R programming. Yes. I'm listening. I'm listening. Python. Okay. Who else? R programming. Yes, somebody mentioned R programming. Another person. Another person. Is that all? I'd like to hear from also.
Structured query language.
What do you say? Structured query language, SQL. Yes.
Power BI.
Power BI. Yeah. I like that. Tableau. MATLAB. So nice. Origin. All this SPSS. Amazing. SAS is also one that people use for analyzing data. But as good as everything you've mentioned, as good as they are, the first tool when it comes to data analysis is you. The first tool in data analysis is what? Is you. That is the first tool. So you want to get you right when you analyze data before you think about any tool. Like we always say in programming, the code is only as good as the person programming it. If you build a software and you don't understand software security, you don't understand how to ensure that your database is not showing on the front end, even though the software may be working, you will find that people can grab the username and password of your users by just doing inspect on Google Chrome. And that's because you don't know how to hide those information from the front end. So it is you. Whatever analysis you do will always be as good as how much you know about the data. Will always be as good as your knowledge of how to analyze data. Before we now move to these tools that you've mentioned. And in this tool, this is Python, this is R programming, this is Julia. I don't know if anybody has written Julia programming before. Julia is just like Python and R also. It's a data science language also for data science, Julia. You have SQL, which is structured query language, especially if you're working with like big data, you will need to understand SQL. Microsoft Excel, if you're working with data that is not like necessarily big data, you can work with Microsoft Excel, because Microsoft Excel usually have like number of rows, either in millions, I don't know the total number that is allowed that you can put on it. But if you're analyzing like very big data, you may not be able to do something great with Microsoft Excel. Another one is Jupyter Notebook. It is not a programming language. It is just more like a graphical user interface where you can write Python language, you can write R language, and some other programming languages like that. And Google Colab, which is what we are going to be using today, is just Jupyter Notebook, but it is online. Jupyter Notebook, but it is online. If you want to use Jupyter Notebook on your local, on your laptop, you will need to install either on Anaconda on your laptop, or you install Miniconda on your laptop, or in your VS Code, you install the Jupyter Lab extension and all those kind of things. But you don't have to do any of those things if you are using Google Colab. With Google Colab, you just go online and type colab.google.com, and you have a programming interface that you can use already without installing anything on your laptop. And the beauty about Google Colab is you are not like using, even if your system is 4 gig RAM, so long you can open Google Chrome, you'll be able to analyze your data in Google. Either it is R language or Python, I think. I'm not sure Julia is Google Colab. Okay, but for me, I'm very biased when it comes to programming. I'm a Python freak. Okay, and I don't apologize for that. I don't apologize for that. I'm a Python freak. So some people, they are R programmers. I love them. I appreciate what they do, but I'm a Python guy. Not the Python snake, though. The Python programming language. Okay, so somebody's asking which of these tools are specific for thematic analysis. Okay, now there are some, how do I put it now? There are some kind of analysis that they build special software for, but you can still use R or Python for thematic analysis, depending on how your data is designed and depending on if there's library for thematic analysis that you can use. So that is more like specific when it comes to like analyzing that data. And today I'm not covering something like thematic analysis. So there are special, I think there's this one that you pay for that they use for thematic analysis. I can't really remember. And that's because my work is not in that area of thematic analysis. Okay. Then with Python, the Python library that we use, pandas. If anybody is doing data analysis with Python, the first library that they will know is pandas. Pandas, which is for data manipulation. The data you are cleaning or data you are wrangling and everything, you use pandas. Then another one is NumPy. NumPy is for numerical operation. And NumPy, if you can use NumPy libraries very well, you can be able to write code that are faster, because with NumPy, you can do what we call the NumPy vectorization. I know this is not necessarily a Python class, but these are some libraries that you will use when you're analyzing data. Another one is Seaborn and Matplotlib. Seaborn and Matplotlib, they are the libraries that we finally use for data visualization that help you to see data, to see all those plots, all those beautiful plots that you see. Then stats model, these are like libraries that we use for statistical testing, which is one of the things we're going to be doing today, like the statistical analysis. Now, SciPy is for scientific computing. They have like different functions that you can use for computing, making things faster for yourself at the same time. So the first thing is exploratory data analysis. And what you do in exploratory data analysis is that it helps us understand the data distribution and patterns. And you can use the summary statistics, which are like histogram, box plot, scatter plot, and all those things to explore your data and see, do I have outliers in my data? Are there missing values in my data, or different kind of things? You do in your exploratory data analysis, if there's a need for data transformation, you will transform your data. For example, if your data set have so many outliers in them, what you do is you can do transformation so that the mean and the standard deviation of the data is the right one that you need. So it will reduce how skewed the data set is. So if you do log transformation, log transformation is just you take the log of each value in your data. So when you take the log of that column of the data that you have, it will ensure that your data is not as skewed as it used to be. So it will reduce the impact of the outliers. And there are different kind of scaling that you can do when you are transforming your data. Then the last thing is that you should know that exploratory data analysis is the key step before modeling or any other process. So if you get the EDA, if you don't have good information, you didn't do the right thing at EDA, you are going to do the wrong thing in all the things that you are going to do, which is the core statistical part of the analysis. And one of the EDA that we do is, for example, box plot. We have box plot. This is an horizontal box plot. Usually in research papers, you will see box plot as vertical box plot, but this is an horizontal box plot just to explain how box plots, how they are. The first thing is that box plot will help you visualize data distribution based on 5 summary statistics. And the number one is the minimum. So it will show you the smallest non-outlier value in your data. And when I'm talking about smallest non-outlier value, is that, let's say I have data set, let's say I'm recording. Yeah, interesting. Imagine you go to a class of 300 level students, a class of 300 level students. I need your contribution. What is the average age that you expect a 300 level student to be? How old should a 300 level student be? I need response. On the average. I need people to respond to me. If you go to a 300 level class, what kind of age would you be expecting? How old should they be? You can unmute and tell me something.
21.
21, 300 level, 21. That's fair. 20, 21. Okay. I need data. Please tell me. This is just 2 samples. I need more. Samples. I need someone to talk. Average age. How old should the 300 level student be?
In Nigeria.
In Nigeria. What do you say?
In Nigeria, 23 years old.
23 years old. Interesting. 18 years old. Okay. Now, from this data set we've collected, imagine in 300 level, you find a 9-year-old boy. You went to a 300 level class and you found someone who is 9 years old. What will come to your mind? I need someone to respond. What will come to your mind? You went into a 300 level class and you found a 9-year-old.
An outlier.
How did he get there?
Exactly, an outlier. That is what? A minimum outlier. Why? You expect that anybody in training level should be 18 years old and above, right? Between 18 and let's say 23 years. So if you gather the ages of people in training level, they will be between 18 and 25 years, thereabout, all things being equal. Now, that is minimum outlier, right? A 9-year-old. Imagine again, in that 300 level, you found someone of 40 years old. What would you say? 40 years old. Even when he's coming to class, like this, you're hearing daddy, daddy, mommy, mommy, the children will be running around the person. 300 level. What would you say? What would be your comment in the class? I need response.
Sorry, I didn't get the question.
If you found a 40 years old person in class, a 40-year-old in the class, 300 level, what would be your comment? What would you think about? Would that be normal? Exactly. Someone said an outlier. Exactly. A maximum outlier. Do you understand now? So in your data set, you can have a minimum outlier and you can have a maximum outlier. And a box plot can easily help you to see this. Now, any value that is below this minimum, the smallest non-outlier value. So in our case now, in a classroom where you have 300 level students, if you take their ages, the minimum, the smallest non-outlier value should be around 17 or 18. It's going to be around here. But if you see someone of 9-year-old, they are going to be somewhere here. You just see a small dot outside. That is an outlier. So you can, by the time you plot your data using box plot, you immediately see that there's outlier in this data. Then you begin to know what next to do about it. Then the Q1, which is the 25th percentile, is also another summary statistics that you get from box plot. Now, the Q1 is showing you what is you can see the range where your 25th percentile of your data, where they fall into. You get that here. Then you have the Q2, which is the median, the middle line in the box. Here, this is the Q2. It shows you the median of what you have in your data set. So the median here, you can see the median is more like the 50th percentile, if you will call it that way. It's like the 50th. If you have 25 plus 25, you have the median. Now, you now have the Q3, which is the 75th percentile, which is the end of the box. Then, when you now go above the 75th percentile, you have the maximum largest non-outlier value. So in our case, in a 300 level classroom, you have someone of like 25 years old as the maximum non-outlier value in 300 level, right? But if this person is 40 years old, they are going to be an outlier. They are going to be a maximum outlier. Now, do you see how interesting it is now for you to make such a plot when you make box plots? So if you collect the ages of the student level students and you just plot it using a box plot, you immediately just see, oh, in this class, somebody is too old or somebody is too young. Then you now begin to look at it like, well, maybe the person started school late, one started school earlier. If you meet a 9-year-old, you're going to be thinking about, oh, is this person a genius? Is this person is an act of God? Is a different kind of thing will come to your mind because it is not irregular, right? And when you look at the whiskers, what the whiskers are just showing is what I've explained the other time, which are all this, the whiskers, they just show the cap of the data. So anything that is outside the whiskers, they are outliers. So if you plot your box plot and you have this dot here or dot here, any dot here, it means they are outlier values. Now, another thing is violin plots. And there are different reasons why we make this kind of plots because they tell us different things. Okay? When we make the volume plot is just like a mix of the box plot and the kernel density plot. Like if you plot histogram, then they made it into vertical point. So if you turn this picture into horizontal, you are going to see that it is just an horizontal box plot and the kernel density plot. And you will see what I'm saying. It's just a box plot with a smoothed histogram. Then it is turned sideways. So with this, you have the distribution, the central tendency, and the spread of the data. So in this kind of data set now, you will see that you have multiple peaks in your data. If you have this kind of box plot, you have multiple peaks in your data set. That means your mean is not just a single mean that you have in your data set. A data set like this will not really be good for analysis of variance because ANOVA, for example, usually have an assumption that your data have like more like equal variance. But this, you see, you have multiple peaks. That means this data set is not normally distributed or the way it should be, that is good enough for a kind of statistical analysis like analysis of variance. There are other things that you can do about such data set. So it shows you the spread. And with this spread, you will see that you have multiple peaks. So you have the minimum, you have the first quartile, you have the median, just like within this box plot that is inside. Then you have the third quartile, you have the density plot, then you have the maximum value. And we see this better. So the middle, which is the white dot, this one you're seeing is the middle value, which is the median, somewhere here. Then the tick bar that you are seeing inside is the interquartile range, which is just a box plot that you have inside. Then you have the wider part, which is the violin. The violin that you're seeing is just showing you the density of the data. In which area is the data dense in? So that is how dense is the data. Is it dense forming a normal distribution, or you can see different peaks, or not normally distributed? Then the thinner part just shows you that there's less data. So if you come around this area, it's a bit thin at the peak. It means you have less data in this region. Here too, you have like less data in this region, and you have a lot of data in this region and in this region. Another thing is swarm plot. Swarm plot. A swarm plot shows each individual the data point spaced out so they don't overlap. So with the swarm plot, you can plot the different categories of your data, but you can see individual points when you plot it. You will see that here, we don't see individual points. We just see the spread. Also, in the other parts, in the violin plot, we don't see the individual points. But if you want to plot different category of data and you want to see the individual points, you can use a swarm plot to still see the individual points. So it's going to show you how the data set is. So you see that around this place now, you have a lot of points close to this area, like that. You have many points in this region. Okay. Now, it looks like a scatter plot, but it is organized into categories. So maybe your category is male, female. You have the plot, the male, the plot of the female, all. And you can see the full distribution of the raw data, the full distribution of the raw data. It is great for small to medium-sized data set, because if you have like millions of observations, you won't really be able to use swarm plot because it's going to be messy. You won't even see all the points together because they're going to be so clustered together. But you have data set around, say, 500, 1,000 observations, maybe. But if you have really big data set from 100,000 and above observation, you can't really use a swarm plot for that. Then it makes it easy to spot clusters and outliers. So suddenly here now, if I see that maybe this blue, I just found a blue somewhere here, I will know that that's an outlier. So I could quickly spot it. Then the QQ plot, which is another thing you do in exploratory data analysis. The QQ plot is just comparing the quantiles of your data set to the quantiles of a theoretical distribution. So we're trying to check the normality of our data set. Does it follow a normal distribution? And a lot of time when you see data follow a normal distribution, you find that the mean, the mode, the median, they are close to each other. They are not so far away from each other. So when you see data set with normal distribution. So when you look at this now, you can see this is the theoretical quantiles, which is like how data should be distributed. Then to compare it to the ordered quantile, and the ordered quantile is just the quantiles of your own data. So you want to see, does it follow a normal distribution? So if you look at something like this, you see that everything you are seeing, they are close to the line, which is this, I'm trying to see this, a bit blue or gray line that you're seeing here. They are all a bit close. They are not scattered across, and they are not forming like S shape, you know? If you plot a QQ plot, and you find out that your points, they are organized this way. I don't know if you see the movements of my mouse. Let's say they are organized in S shape. Maybe they go this way and they come this way, and they are not like clinging around this line of fit, then it is not normally distributed. But in this case, you can see it is a bit often normal distribution. So, and it helps you visualize how closely your data follows a specific distribution. For example, you can have data that follows more like maybe another kind of distribution. And like I said, the x-axis shows the theoretical quantiles, the y-axis shows the actual quantile from the data. And if the point falls along the straight line, that's what I'm saying, that it follows the right distribution. And if it doesn't fall across it, along it, then it doesn't follow the right distribution. And the thing about when your data is not normally distributed is that they will not really follow the assumption of the kind of analysis that you want to do. So for any kind of analysis that you want to do, you need to know the assumption of that kind of analysis. So for example, linear regression, for example, has its own assumption. When you want to do analysis of variance, it has its own assumption. So you can see what I'm saying, that whatever analysis you want to do will only be as good as you that you're analyzing. So if you don't know the things, you just use any kind of statistical test and everything on your data without knowing what rule should I follow to analyze this. And I should have changed this. It is the peer plot, not the QQ plot. So, and this is the peer plot. And what you are doing with the peer plot is you want to see all your categories. Let's say you have male, female data, and you just want to plot their distribution together on the same plot and see how they overlap into each other. So with this now, let's say it is a male-female plot, I can easily know that, and let's say it is their age that I'm collecting. I can easily know that, okay, there's still an overlap in the ages of male and female in the classroom and things like that. And it helps you visualize correlations, clusters, and distributions at a glance. If you separate the group, it will show you the outliers, of course. Once you see this tail of the plot, if this tail of the plot is just long this way, that means there's outlier value in that region. So to move fast now, the last step, which is on the statistical model, is like the analysis of variance, ANOVA. I'm sure a lot of people might have heard about ANOVA before. And what it's doing is it compares means across multiple groups. So if your data set is not normally distributed, analysis of variance will not do well in telling you what you want to learn from the data. So it tests whether the group means are significantly different from each other. Then it requires assumptions like what? You can see normality and equal variances. So what it just means is that the data needs to follow a normal distribution. And after ANOVA, when you analyze your data with ANOVA, it's going to tell you maybe there's difference in the data or in the samples you have given to it, or if there's no difference in the category that you are trying to analyze. But you need more. If it says there's significant difference in this thing you're considering, let's say there's significant difference between male, female, or something like that, you need to know for that, okay, if you have like 3 samples, for example, let's say you're comparing salaries in Lagos, salaries in Abuja, and salaries in Akure, for example, for the same kind of job. Let's say the job role is, let's say factory manager. If a factory manager in Akure, if a factory manager in Abuja, if a factory manager in Lagos, are there significant difference in the salaries? So you collect the salaries of the different factory managers that you know in Lagos, you collect salaries of the different factory managers you know in all these places, and you analyze them. And ANOVA tells you, based on the p-value, that there's significant difference. Now you need to know, is it just that there's significant difference in the 3, or there's significant difference in Lagos and Abuja, or Abuja and Akure? So it's going to dig deep into what you want to know. And that's why we call it the post-hoc test, or what people call generally as follow-up tests. So if you get a significant result from ANOVA, you have to do a post-hoc test to really understand if it is true for each group, between the group. Then identify which specific group differs. Then it controls for type 1 error rate. And I'm going to tell you what type 1 error rates mean. I will see an example. So look at this example of hypothesis testing. This is the null hypothesis. The null hypothesis tells you there's no effect or there's no significant difference. The alternative hypothesis is telling you there is an effect or there's significant difference. And what is type 1 error? It's simply the false positive. You reject the null hypothesis when the null hypothesis is actually true. So let's say your analysis of variance is telling you there is no significant difference, but you claim that there is significant difference. And type 2 error is the false negative, where there is no significant difference, but you fail to reject it. There is significant difference, but you accept that there's no significant difference. So instead of rejecting null hypothesis, you are accepting the null hypothesis. And you can see an example of the type 1 error and the type 2 error here. So look at the type 1 error. Because this man has big belly, you are saying the man is pregnant. That is type 1 error. It is false positive. Why? Who can tell me why? Who can tell me why quickly? Why this is type 1 error? Why? Why it is false positive? I need someone to talk to me. He's a man, exactly. He's not expected to get pregnant. But the same doctor is seeing someone who is pregnant like this, a woman, and is saying, you are not pregnant. Type 2 error, false negative. All right, so that is the way it is. So the post-hoc test helps us to avoid something like this. So let's move to practical. Okay, so let's get our hands dirty briefly. Okay. Now, every research or every data you want to analyze will always start with a problem. You are trying to answer a big question. So there's always a bigger picture in mind when you start analyzing data. So here, the problem we want to address here is that there's a farmland. They've been like gathering data on their crop yield, the farm activity that they are doing. I can use this kind of example because these are the kind of data set that I work with. Now, the farm manager wants to know whether the amount of irrigation significantly affect crop yield. So, and when we talk about like irrigation is just like the quantity of water for those who are not like agriculturists or something, but I know everybody should know irrigation in a way. Is the water, the water you apply that doesn't come through natural precipitation, like rainfall. So you can irrigate your fields, either you are using the different kind of irrigation, maybe sprinkler irrigation, or you lay down pipes and they release water onto your plants, or different kind of things that you do. And this irrigation, you can do them at levels. You can decide to have low irrigation, that is the amount of water you are doing manually on your crop, they are low, high irrigation or medium level irrigation. So the farm manager is saying, we have the yield data and we have the irrigation value for the irrigation levels that led to each kind of yield. Your goal is to analyze the relationship and determine if irrigation practices should be adjusted to improve productivity. So the farm manager is like, we've used low irrigation, we've used medium irrigation, we've used high irrigation. You are our data analyst. Tell us, should we keep using low irrigation? Should we keep using high irrigation, or should we keep using medium irrigation? So these are the kind of problem that you might face. And it could be that you are trying to publish a paper on the impact of irrigation on crop yield. And you've done your experiments, you've gathered data and every of those things for crop yield. So that is one of the things that you can do. So to answer this question, I've written the code. I have the code this way. You can just run it. You can download. I will send this to Mr. Philip, and you can just, I can share this, and you can just open it on Google Colab, and you will repeat the same thing directly without having to install anything on the laptop. So you have the libraries. Like I said the other time, NumPy, Pandas, start. This one is just start annotation to add annotation to your plots and every of those things. And I will just run the library. So when I'm running it, it will connect to their server. You can see it turn into green, then connect. So as I'm connected, I have access to the Google Compute Engine using Python at this point. Now, it's saying there's no module named start annotation. Why? Because start annotation is not installed by default, or was not installed by default on Google Colab. So I needed to install it myself. So to install it myself, I just go to a new cell above, and I just do this, and I say pip, and I say install, and I say start annotation, and I run it, and I wait for it to install. Okay, downloading, installed. Wait for it to stop running. Okay, and that's done. Now when I run it again, I don't get the error anymore. So I set the size, the figure size of my plot. I usually set them in the beginning. And the reason is because I want all my plots to have the same size. And I don't want to be repeating that line of code of, oh, use the size of the figure size. So that's why you see the figure size I'm using. Now, because, I don't have data for any farm, I needed to use a synthetic data. So the synthetic data that I'm using is going to give me yield value. For example, at low yield, it will generate random data that follow a normal distribution. So in Python, you can tell it, generate data set that follow a normal distribution. I'm telling it that this is the value that I want to generate, like up to the highest at 150 time steps in generating the random value, then 20 of each of those. So for low irrigation, I'm generating this data set. For medium, I'm generating this data set. And for high, I'm generating this data set. So I'm using Pandas, which is the library, to generate them by just saying, okay, low times 20, whatever value you have here, it is in 20 places that we have in the columns. We have 20 rows, medium 20 rows, high we have 20 rows, and the yield that will be assigned into irrigation. So when you see low times 20, low is a value. I'm just saying in a column, repeat low 20 times. Medium, repeat it 20 times. That's why I put times 20. That's why I like Python. It is like speaking English, you know? Isn't it like that? If you have something against Python, let me know in the chat. Just tell me, no, Python is bad. All right. So, and this is not because Python is paying me, by the way. Okay. So, high multiplied by 20. Python is live. Okay, I didn't do that yet. Thank you, my G. So, yield, I'm saying whatever value I have in low yield, attach it here, concatenate it together, whatever value I have in medium, whatever value I have in high. So, this is just me generating the data. So, if you run this, you will get the same value that I'm getting. And why will you get the same value if you run this code? Because I use what we call the random seed. If we have the same code here, as I used 42 in my random seed, if you take this code to Calgary in Canada and you run this code, you will get the same value that I'm going to generate. But I didn't put random seed. Let's say I comment out this part of the code. If you run it different times, you will get different kind of data set every time. But if are in the same band, but the values are going to be different every time. So because I want you to get the same values that I get, I'm going to ensure that I have this random seed attached. Then I run it and the data is generated because it's not a lot of data. And to see the data set, I just say data.head, and you can see data.head, this is it. And you can see the low value, the yield. So because I can decide to see everything. So if I put 20 here, I will see everything. So you can see, it will show me for low, it will show me all the 20 that I have for low. If I want to see it from the end of the data upwards, you just put .tail. Isn't Python sweet? You see, very simple. Head, tail, head, very simple. Okay, if you don't know how to program Python, I'm encouraging you to learn it to be good. Okay, so you see, that's just it. So we have two columns in our data, which is the irrigation level and the crop yield. And that's it. Now, let me reduce it back to 5. So the default is 5, then I have this, the tail. Now, the basic statistics that we want to do is the summary statistics. We just want to see a summary of our data. So it has been grouped by irrigation, and I want to describe the data as it is grouped by irrigation. So I want to be able to see the summary statistics of low irrigation separately, medium irrigation separately, high irrigation separately. And this is it. So you will see that if you look at the yield count, how many rows of data do we have? We have 20 in high. The mean of our high irrigation is this number. This is the standard deviation. This is the minimum value. And this is the 25th percentile. This is the median value, the 50th percentile, the 75th percentile, and the maximum value. Also, under the low, I have it this way. The yield that they get in low irrigation and in medium irrigation, I have it the same way. So the process has started. So I'm already exploring the data. So I am not learning some information. Oh, the mean of my yield is around this, the mean of this is around this. So I keep going. Now, I mentioned box plot the other time. When you want to do box plot in Python, because I have imported the visualization library for box plot, which is Cbon. Over here, I say import Cbon as SNS. So I will just use Cbon to make a box plot. And I just run this, and you can see my box plot. This is low irrigation. This is medium irrigation. And this is high irrigation. So the box plot now, when I look at it, I see that in my data set, I don't have any outlier. Because if I have outlier, I will have one value at the top or at the bottom. At the bottom or at the top, at the top or at the bottom. But I don't have any points that is showing. That means my data set, I don't really have any outlier value. So I am seeing that. I am seeing where the median of my data set is the 25th percentile, the 50th percentile, which is the median, the 75th percentile, and the maximum value. Just like I explained box plot, this is box plot. Now, I'm seeing something here. One, I now know that there's no outlier in my data set. I can see that, and I can see where the median of the data is. So in high irrigation, I will see that the median is very, very close to the mean. It's around the mean value. The median is around the mean value. So in high irrigation, do you see? If you check the median, which is 1,502, do you see it is very close to the median value, to the mean value? Are you getting me? I need to see signs that you're following. Okay? Do we understand up to this point? I need response. Do we understand up to this point?
Yes, but what are
Okay.
outliers?
Outliers. Interesting. Samsung. What is your name? Your main name? I know you're not
Oluwatobi.
Samsung, of course. Oluwatobi, okay.
Yeah.
Okay. I explained outliers the other time using an example of a 300 level classroom. And the example is that if you go to a 300 level classroom, people give me data set and say, oh, the minimum age in 300 level should be around 18 years old, and the maximum age should be around 25 thereabout. So if you go to a 300 level classroom and you find someone of 9-year-old or a 9-year-old person, okay, you will see that as an outlier because you don't expect that you have a 9-year-old in 300 level, right? Samsung, Oluwatobi, right?
Yes.
Or in the 300 level, if you find someone of 45 years old, what will you say? It's an outlier in the class.
Yeah.
All right. Yeah, exactly. That is outlier. So let's say under low yield, you can see that the maximum with that outlier is around 1,000. If I check here, under low yield, it's around 1,236 thereabout. Imagine I suddenly have 1,600 in low yield. You will see that 1,600 is very far from every other value we have. So it's going to seem like an outlier. So when I look at this data set as a data analyst, let's assume I suddenly have 1,800 under low irrigation rather. I have 1,800. That information will come to my head as, did they record this data wrongly? Did they mean to write another number and they wrote this number? Or maybe an act of God happened that suddenly in one of the years where they applied low irrigation, they got this much. All right. The outliers will tell you many things. Either things are going wrong or there's something special that is happening. Like if you find a 9-year-old in 300 level, it's either there's something going wrong with our school or there's something special that is happening. All right. Now, then the volume plots. So the volume plot will help us to see the density. And I'm going to plot it now, and you can see the density. Now, if you look at the volume plot, for example, this on low irrigation, you will see that if you bend, I don't know how to, if I turn this into like something landscape, it follows a bit of a normal distribution in a way, because there's value and the mean and the mode and the median, they are closer together. So you will find them following something that looks like a normal distribution in a way. So if you go to check low irrigation, for example, in your data, this is the mean, 974. Do you see? And this is the median. Do you see that they are not far from each other? The median and the mean, they are not so far from each other. So that's why here it looks as if it follows a kind of normal distribution. And the peak is just showing you how many high value you have in the data set. If you have few high values in the data set, maximum, around the maximum, you see that it's thin. You have few around the low yield, that's why it is thin. Okay. Now, another one is a swarm plot. The swarm plot is just telling you each observation that you are seeing plotted. So that's just the swarm plot. Individual observations in each group. Then the QQ plot, which we use for the normality check. So if I click this, which I'm getting from the SciPy, if I plot the QQ plot, you see something like this, the normality check. Now you see that what I was saying the other time, this is looking like it is forming like a S. If you take it from this edge, like you want to write S, but it doesn't fully form something like that. Everything is still around the line, around this red line. So you can still say this data set is fairly normally distributed. So, and the only reason this data looks like it is normally distributed is because when I was generating the data, I already informed the code that I want to generate data sets that follow a normal distribution. So I already said random.normal. If I didn't add normal, it should just generate any kind of data set for me. Okay. Now, normality check, it is fairly normal. So because the data set is fairly normal, I can move ahead to do something like analysis of variance. But had it been this data set doesn't follow a normal distribution, doing an analysis of variance would not give you the truth, in the difference that you are checking for. Then the pair plot, which is like the pairwise relationship, you can see this, how the yield at different irrigation levels from low to medium to high, how they overlap under each other. Here now you will see that under low irrigation, which is this part, under low irrigation, you still have some values in low irrigation that are around the same value of medium irrigation. You have some value in medium irrigation that are around the values of high irrigation. So that is telling you something. And the reason we are having something like this is because whatever we generated is still following kind of normal distribution in a way. Sometimes you can have these pair plots where they don't overlap. So when they don't overlap, there you automatically know that whatsoever yield you are getting in different kind of irrigation, they are far away from each other if they don't overlap at all. Moving now into the ANOVA test. And this is the code to do the ANOVA test. And in the ANOVA test, one of these we want to know in the end is the p-value. The p-value. And the p-value will tell you whether there's significant difference in the irrigation that we're checking for. So if you get a p-value of 0.05 and below, 0.05 and below, you can conclude that there is a significant difference. But if you get a p-value that is greater than 0.05, you can conclude that there is no significant difference. So as a result of that, you can easily say, farm manager, it doesn't make any difference what irrigation you use. Okay? It doesn't make any difference what irrigation that you use. Remember, analysis of variance doesn't tell you which one is the best irrigation. It only tells you that the irrigation have different performance. Okay? The irrigation, they have different performance. So now you by yourself will now see, okay, now that there's difference in the irrigation, I will now say, okay, which one is the best irrigation? Then I will look at the measure. I will look at which one gives me the highest yield. Then I can conclude that, yes, I can go for that one. Now, when I run this for the ANOVA, you can see the p-value is around 0.000000000 whatever. Okay? So automatically it's less than 0.05. So what do we conclude here? What do we conclude here? I need someone to tell me, what would the conclusion be?
There's no significant difference.
No.
That there is
significant difference.
Actually.
Exactly, in the irrigation, there is significant difference. So now that there's significant difference, we want to follow it up. Is it that the significant difference is only between low irrigation and medium, or the significant differences between medium irrigation and high irrigation, or the two, how do they interact with each other? So I will run the post-hoc test, and you can see when you compare the high and the low, what do you see here in the post-hoc test? That's why I love Python. It will tell you all this information. What did it tell you to do? Reject is equals what? Reject equals what? Can you see it?
Equals to true.
Equals to true. It means for high, between high and low irrigation, reject the null hypothesis. And what is the null hypothesis? The null hypothesis says there is no significant difference. When you compare high and medium irrigation, it also tells you to reject it. Reject is true, which means there is reject that there's no significant difference because there is significant difference. Then between low and medium, you should also reject the null hypothesis. So based on this now, we can conclude that to the farm manager and say, oh, farm manager, there is difference in the type of irrigation that you use. In essence, irrigation type has a significant effect on crop yield. That is how you conclude such a research. And here, I want to see the p-value adjusted. And now, when you want to present this in your paper, how do you present it? That should be clear in your paper what you are doing. So that is what this code in this part is for. And what it's doing is that it calculates the summary statistics, it creates the figure, it adds the error bar on the figure, and the error bar can be plotted in different forms. Sometimes people use mean and standard deviation for their error bar. Sometimes people use 95 and 95th percentile for error bar. Some people use mean and standard error for error bar to plot their error bar. For me, in most of my research, we will use mean and standard error a lot. So I always use mean and standard error. And standard error and standard deviation is simply, standard error is simply standard deviation over the root of the number of samples you have. So if you have 20 samples, your standard error is going to be the standard deviation divided by the square root of 20. And we format the axis, the crop yield, the irrigation level, crop yield, irrigation level, and the PS, low, medium, medium, high, low, high, then because we want to annotate them. So here, I think I was calculating the standard error somewhere here. So add error bar manually, standard error, and this is what I did to calculate the standard error. So summary SEM, and the standard error is just standard deviation divided by the number of sample, the root of the number of sample. So when I plot this, then you have a plot that is in a way paper worthy. Depending on you, you can reduce the size of each label and all. So with this now, you can put this in your paper as the outcome of your analysis. So what is showing you here is, this is showing you like the different significance. So when you have this star, multiple star, if it is one star, it shows that it's still significant. It is very significant. That is the difference between them is huge. So that is what you are seeing here. That's what your post-hoc test shows you. You can see when it's one star, it is still significant. If it is NS means not significant. It should by itself plot there. 2-star means very significant, really significant, a lot significant, depending on how small the p-value is, starting from 0.05 downwards. And this is what you have here. So if you put this in a paper, I'm certain that the reviewer will be happy with you. And they wouldn't tell you, change the plot. I can be certain about that because it is very, very informative, because it's showing the information that you want to see. So on that note, I rest my case. Thank you very much for the day. Any question?
Oh, wow. I think at some point I had to try to remember where I stopped my coding class. Maybe I had to, to go back to my coding class. But this is really, really very informative, and for people that do research a lot in the social sciences, in the sciences, these are some things that you would need to do your analysis. And I think it's very straightforward. Everything inside one code, it generates a result, put it in your project or your thesis, whatever, and you're good. Thank you so much, Dr. Meshach, incoming Dr. Meshach, for that thorough and well-explanatory presentation. That's amazing. I could imagine the kind of time you must have put into preparing for this. And I mean, it's all example driven, something that you can easily follow and not just theoretical. All right, thank you. I think there's a question earlier. Someone was asking about when you were talking about different type of tools for analysis, that which of these tools are specific for thematic analysis?
Yeah. Yeah, I responded to it. Like
Oh, okay.
I can't remember a specific tool, but in vivo, yes. In vivo. I just remember. In vivo. Yes, they use it a lot for qualitative analysis. I just remember. Yeah, in vivo. Because my friend did things that deal with thematic analysis in during his master's. So this software, it is paid. So yeah, it is paid, it is not free. So for me, if I have to do something that Invivo does, because let's say I don't have payment or my university, if they don't have the license, okay, let me see. Okay, they have the license at our university. Wow, this is so good. Come and study at Aarhus University. Okay, so because you get license. So for me, I would just look at what is Invivo doing, what question do I want to answer, and because I love to code, I will write my own code without paying Invivo in a way if I don't have money. So, and in these days that you have ChatGPT, you can just tell it what you want to do and tell it like, oh, InVivo does this. I want to use this part of InVivo. Is it possible to just write a code that can achieve this for me that InVivo does? But no matter how you want to take ChatGPT to help you code, if you don't really know how to code, it will not be useful for you. So I tell you, learn how to code, then use ChatGPT as a partner. All right. You can tell it to even teach you to code. Tell it to teach you. So if you write any line of code in ChatGPT, tell it, okay, what is line 1 doing? What is line 2 doing? What is line 3 doing? And yeah, every of those stuff.
All right, thank you. Do you have
I could see
any other?
someone in the chat. I could see someone in the chat telling me I'm a good teacher. Okay. That's my wife telling me I'm a good teacher. Okay. Yeah.
Nice one.
Yeah. Thank you very much.
Yeah. Any other question?
All right, I have a question.
Okay.
Yeah. Please go ahead.
All right. My question is, for those that don't know how to code or don't know how to use Python, uh, using Excel or let's say XPSS, because me, I'm familiar with XPSS, so are
Yeah.
we going to arrive at the same thing?
Certainly. Certainly, you will arrive at exactly the same thing.
Okay.
I mean, when we're doing bachelors, like I used SPSS, right? We were doing bachelors. Even though I could code a little then, like 2017, like I could write some of these things in code, but not as I am now. I used XPSS. When I was doing masters, when we did our environmental analytics course, we used SAS. But the thing in SAS is that you still have to write code. And even in SPSS, if you can write code, you can give command, you will maximize SPSS better. You will maximize SPSS better. So that is one of the things that I want to say. You can achieve the same thing with SPSS. But where the challenge usually comes from is when your data gets bigger. When your data gets bigger, imagine you are testing global impact of irrigation on crop yield. You can't really use SPSS for that because SPSS is software. You install it on your system. It is using your RAM on your system. And if your system doesn't have like maybe 40 gig, 60 gig kind of like RAM, it is slow, it's very slow. You know, you are limited in how you find the expression. So the beauty about programming stuff is that you can find the expression to whatever you want to do. You are not limited by what has been pre-programmed into a software. So in this case now, I can find the expression easily. I didn't have to do multiple file. I didn't have to do all those kind of things. I didn't have to, everything I can just do it in one place. So I always advise, if you want to go for a data intensive career, you understand, a data intensive career, you need, like, it is a must. If your career path is data intensive, it is a must that you are able to code any kind of code. R programming, for example. R programming, for example, is a very good starting point. Really nice. So it is good that you know how to code. Like today, it is easier to learn how to code. You can just go to ChatGPT and say, see, ChatGPT, I don't know anything about programming. I want to start learning programming. Teach me R programming. Design a structure or study for me. And I tell you, ChatGPT will teach you how to do. But for those who are interested in learning, let's say you want to learn Python, you can just send me an email and I can share with you resources that can help you learn Python. For example, a video that can teach you Python from beginning to at least intermediate. I can share that with you if you don't mind. So let me just drop my email here. Sorry. You can just send me an email.
Sorry, I have a question. Oh,
Yeah, I'm listening. Oh, I'm sending it to Philip. I want to send it to everyone. Okay. Yeah, that's my email in the chat. You can just send me an email. Or just search my name, my email on LinkedIn and message me via LinkedIn. Like Aderele Meshach. I'm the only one bearing that name. So you won't find two people bearing such name. Okay. Somebody says they have a question. Who is that?
There's a question in the
okay.
chat. Before that,
Okay.
there's a
Okay, what's
question,
your
like two
advice?
questions
Yeah.
here too.
What's your advice for somebody desiring to build a career in data analysis? Okay, now you need to decide. Am I doing data analysis for research or I am doing data analysis for business? Okay, when you make that decision, that will determine what you learn. If you are doing data analysis for research, you will really need to know these things that I am teaching you for research in academia. You will really need to know it. You also need to know it if you are doing data analysis for business, but that is not your starting point. So if somebody wants to become like a data analyst, okay, with respect to business, the first thing I will tell you to learn is Excel. The first thing I will tell you to learn is Microsoft Excel. If you can know Microsoft Excel very well, it is a very good starting point. Okay. When you know Microsoft Excel, you don't have to finish one before learning the other. You can go simultaneously. So if you learn Microsoft Excel, you learn either Power BI or Tableau for data visualization, Microsoft Excel for data cleaning, using pivot table, all those kind of things. Then you have Tableau or Power BI. They are just different companies, Power BI and Tableau. Okay, one is by Microsoft and one is by another company. Okay, Power BI or Tableau or Google Studio, but Power BI or Tableau is like the ultimate one that people use. Then I will advise you to now learn SQL. Do you see the order? Don't learn SQL first. You'll be discouraged. You don't want to continue. I promise. Because it is programming, SQL. So before you start learning the programming part, I will advise you to learn those interesting, very much a bit easier part. Then learn SQL after learning Power BI. Okay. So when you learn SQL, just those three things they are enough for you to get an entry-level job if you do good portfolio project. If you do good portfolio project, just those three things, they are enough to get you an entry-level data analyst role. But if you want to take it further so that you can really be unique, then you can now learn Python or R programming. It is either of them. You don't have to learn the two. You can now learn either of them, either Python or R programming. So you can learn both. So that now adds to your crown. Especially in the days of artificial intelligence, they expect that data analysts know how to code in most companies now. Okay. But if you learn those three, Excel, one of Power BI or Tableau, then SQL, you're good. Yeah.
And the second question, do you have a mentorship class?
No, I don't. No, I don't. The best way that I do informal mentorship is reach out to me via email. Tell me what you need, what you want to learn or something. Then I will reply to your email and give you, okay, if you do this, if you check this, if you check this, check this. And I promise, if you follow whatever I'm telling you, you are certainly going to benefit from it. So that is the way I I do it. So it is an informal mentorship. And when I tell you to do something, if you don't do it and you come back again and everything, I will ask you for, I told you to do something before, have you done it? Yeah. But in the future, in the future, I have in plan, but not now, it's the distant future, to have a mentorship class where I'm paying people to mentor them. So, it's otherwise that people pay to get mentorship. So in the distant future, just like what my brother is doing with Rising Stars Initiative, we're going to be having something like that to mentor people, not just in data science, in other things, where we pay them to be mentored. So that is going to happen in the distant future. Yeah.
Yeah, yeah. Can go ahead.
Yeah. My question is like this. So, for my research question.
Okay.
Okay. Now, how do I relate my chapter 4 with the research question?
Nice. Your chapter 4 is your discussion. Your discussion. Okay. Let me do a simple discussion of this. This is one objective, right? In my research question. Normally, if you are doing your research, we have like maybe 1 or 2 or 3 objectives. Now, my discussion, when I'm talking, I will start talking about data distribution in my discussion, trying to see that I'll first show this figure, like the box plot. You understand? I'll first show this figure in the box plot and say, okay, based on the data, figure so shows that there's no outlier in the data, and all the data set, all the crop yield across group are concentrated between so region of number, maybe 800 to this, 800 to that, and everything. And you can discuss around that. Then if you see outlier, there's no so much data here, right? If you find an outlier, you will say, oh, an outlier was found and blah, blah, blah. And this kind of outlier, and this kind of outlier is a result of either data error or the data collection, or an act of God happened in 2016 in the crop yield, that an act of God happened and suddenly there's immediate high yield that we cannot explain. All right, you will say that in your paper. There's an act of God, right? If it's an error. For example, if you are discussing, let's say 2020 yield year and there's COVID, for example, people could not really go to their farms. Okay, you can say, oh, the reason there's low yield here is not necessarily because of irrigation. It is because of COVID, because we couldn't go to the farm. And when we didn't go to the farm, we didn't add fertilizer to our crop. We didn't add, all those kind of things that we did. We didn't do the weeding. We didn't do other stuff. Okay. Now, when you now come back to the core that you're now discussing, which is this, you now begin to explain the difference. Then you cite different papers and now say, okay, paper A, Philip Adebayo 2025, Adebayo 2025 found that irrigation affects crop yield significantly. And our study support that. And I've studied in figure so based on our p-value supports whatever Philip Adebayo has found concerning irrigation. Okay? Now, you now see another study. That's why you don't just look for study that supports whatever you found. That's why you have to read a lot of paper. Before you start your analysis, you will read the papers that have been published in that thing you want to do. So I will now say, okay, these studies are supporting the irrigation. There's significant difference in the impact of irrigation. Study B is saying, however, I'm looking for who asked that question. Let me just use Solomon Ito. You know Solomon, that's the name that came to my mind. Solomon et al. Found out that there's no significant difference in the impact of irrigation. Now, what was the argument of Solomon? Solomon's et al. Findings negate our findings because Solomon et al.'s research was conducted in the north. The soil is different from the soil in Akure, where I conducted my own research. So there's probability that the soil is impacting Solomon's finding. Or Solomon did find significant difference because herdsmen went into the farmland and they destroyed the farm. You understand? So your discussion, your chapter 4, is not just talking about you, your work. It is about talking about how does other findings support your own finding. So you start talking about like what you found, then you begin to talk about other studies that support what you found, and at the same time, studies that negate whatever you found. That is how you have a strong discussion in your paper. Then, when you're summarizing your chapter 4, you begin to talk of your own kind of limitation. That probably you understand that you found that there's no significant difference. However, you are giving yourself that opportunity that there might have been bias in the data that was recorded for the analysis. Do you see all these things I've said like this? I can write 1,000 words or 500 words discussing just this figure, referencing other papers. So in that discussion like this, I might have referenced about 15 other papers that have done the same kind of study and begin to see how different they are. Then you synthesize everything together and you get to your chapter 5, which is your conclusion. And in your conclusion, you are saying that for a farmer, your conclusion can be bold. For a farmer to get crop yield, they must ensure that they are using the right level of irrigation, because my study have found that there is significant difference in irrigation, in the impact of irrigation level on crop yield. Both finding. So somebody can cite you too in the future and say, oh, so it all says there's a great difference, so we care about irrigation level when we are doing it. So that is how it is. You see? That's it.
Yeah.
Does that answer your question?
Thank you so much. I really appreciate it.
Yeah. I think Philip can add. Yeah.
Yeah, let me add something to that. For those that work with model or for engineers that work with multiphysics, yeah, it can be any kind of model. It can be multiphysics model. It can just be model that generate from maybe you have a linear plot and you want to see the linear, but maybe you plot X and Y, you have your function. At times, you might also want to explain what you are expecting. Maybe your argument is you can call the farmer. The question we are trying to solve here is irrigation level and crop yield.
Exactly.
So you
Crop
can
yield. Yeah.
say crop yield is a function of irrigation level. Y is equals to fx plus whatever. And you can
Yeah.
also argue or talk about your discussion around that. If it is a multi-physics driven research that you are doing, like you are using the likes of COMSO, then you want to go into the physics. What is the
Yeah.
physics saying? Then you have to explain what you are observing based on the physics of the problem.
Exactly. So, for example, here now, in agriculture, there's something we call the biogeochemistry of soil. Okay? And that's why I didn't want to go deep into explaining that. Because the things that contribute to crop yield, it is not only the irrigation, but because the research question is trying to check irrigation level. So you can dig deeper in your discussion if you want to read it with verbals. If I'm a reviewer and you do that, I will send your paper back and tell you are talking too much. Okay? But if you want to go deeper, because that would be like your verbals, you are going out of context, So you can begin to say, okay, yield is not just a product of irrigation. The smart way to do it, yield is not just a product of irrigation, but our research is trying to simply check how irrigation affects them. This is one way ANOVA. There can be two-way ANOVA that we are checking low irrigation plus low fertilizer. How does it impact yield? Medium irrigation plus, we can check all those kind of comparison also in two-way ANOVA. So there are multiple things that we can do, but this is the simplest one that you can do. But everything you should remember for those that are writing research, your chapter 4 is always about what have I seen and what can I say about what I have seen. Then, who has seen the same thing that I am seeing, and who is saying what I have seen is not what I should have seen. It's confusing, right? Okay. What have I seen? There's no significant difference, right? What can I explain about it, right? I'm saying, oh, there's no significant difference because the irrigation level are different. Then who has found the same thing that I've seen? Oh, Adebayo Eto says the same thing. Solomon, who is negating whatever I've seen, Solomon said it is a lie. It is not accurate. Then I now argue. That's what we call our discussion argument. All right.
So bringing your argumentative cap. I think the
Yeah,
lawyers
I
will do
can
much justice on.
I can show you a very simple example in my recent paper that I have here, where I was looking at the environmental impact of different fertilizer, crop residue, and cash crop. Okay. Yes. Where is the paper not open?
Is it open access?
Yeah, it's open access. I don't know why it is. We
Yes.
pay so much for it to be open access. So let me put the journal so that you just give me a CVR link directly. Oops. I don't know. This is strange. I was expecting the CVR link, but okay, yeah, I can see it here. Yeah. So you can see here, I was making an argument somewhere in my paper. And what is my argument? This is like the crop yield data. And here, I was making different arguments. I do the same maneuver that I'm telling you here. And I was checking the difference in the different kind of cropping system. This is organic fertilizer dominated farmland, synthetic fertilizer dominated farmland, the blended system. So I'm testing this hypothesis on if we don't use, they used to tell you organic farming is good. And some farmers say, organic farming is not good though, synthetic fertilizer is the best though. So I'm testing the environmental impact. What if instead of saying organic farming is the best or synthetic farming is the best, what if we have a farmland that is combining both manure and fertilizer and synthetic fertilizer together on the same farmland? So what is the environmental trade-off? So I am introducing this to knowledge that if we blend this system together, we can get good crop yield and we can reduce the environmental impact of agriculture. So I start discussing each. How does it affect nitrate leaching? How does it affect N2O, these gaseous losses from N2O plus N2 to NH3, ammonia emission? What is the comparative analysis with respect to nitrogen use efficiency? How different are they within each other? So you see what I'm saying? And in the discussion, I begin to make those arguments. And the conclusion, you can see something I'm saying here is like, according to the result presented in the study, it can be concluded that solely relying on either organic or synthetic nitrogen is generally not beneficial for reducing excess nitrogen. This finding underscores the importance of mixing them together on the same field, emphasizing the significance of manure transport and strategic distribution. Do you understand? This statement now, I'm the first person making it in this whole world. You see? That's just a joke. But that's the idea. All these things that you see here is for me to arrive at this conclusion. These 2 lines is all I just want to prove that we should mix fertilizer. But even though I talked about like mixing fertilizer, I now need in my conclusion to begin to discuss what is the cost if we mix them. You understand? What is the economics of it? What is the feasibility of mixing it? So you can go and read this paper. It is on Sevia. It is open access, and you can read it. Just published it recently. So, and you can learn from there how to discuss. So, yeah. Thank you very much.
Thank you, sir. Please, last question from my friends.
Okay.
Wonderful presentation. I really learned a lot. But my question now is that what of those that are into social science, let's say agricultural economics, they are more of surveying work. They make use of questionnaire to collect their data and all that.
Yeah,
So
yeah,
can we use the same Python to code those questionnaires and get our
certainly,
result?
certainly,
Yeah.
certainly,
Okay.
certainly. Normally, we used to do like you can use SPSS for questionnaire, for example. You understand? What makes a questionnaire data a bit different? When you want to use SPSS, you have to convert whatever you are using into code. All your yes, no, agree, disagree, strongly agree, salary, you change them into
The
code, right? You change them into one,
numbers, yes.
zero, two,
Yes.
those kind of thing, right? You do all those things.
Yes.
It is even easier to do that in Python to convert into code. All the stress we used to do in Excel, that will be changing this, changing that, doing finding and replace. In Python, you will achieve everything with like 3 lines of code. You understand? You achieve everything with like 3 lines of. If you do it in Python, you just tell it, okay, this is the questionnaire, okay, that you have. These are all the columns that you have there. This means this means that, this means that, and you run. You change everything for you, straight up. So it makes the workflow faster. You understand? Yeah.
Yes. Yes. Thank you, sir.
All right. Thank you very much. Yeah.
All right, I guess that's the end of the question and answer session for today. There's somebody asking about having the code. I think you promised to send that. Are you comfortable sharing the slide as well? So you can
Yeah,
send
yeah, yeah,
both
yeah,
to
yeah. I will
my
share both the slide and
you
the
can
code to the
yeah, you can
email.
send it to my email. And for those that joined last time, I think I shared the link where you can get the materials. I'm not sure if we have everybody here, but I can share the folder link again before we leave the call today. For all the materials presented by all the guest speakers from the last 2 weeks, you can access those materials there. Let me get the link. And if you want to kind of rewatch the discussion for today and the past 2 Saturdays as well. You can check our LinkedIn page. Sorry, let's say LinkedIn page. You can check our YouTube channel and you can find it there. Let me see if I can share that again as well. Uh, I guess we have come to the end of the session for today. And I would like to say a very big thank you again to our guest speaker today, a very good friend. We've been together for how many years now? And
It's 2021, right?
since 2021, I'm still sure that we still have great things to do together. And thank you for honoring this invitation to speak. Hope you guys know that this event we are not paying on any of the guest speaker. It's purely based on friendship level, and we are all joyfully trying to make impact as much as possible that we want to do. So, can we please appreciate our guest speaker for the sacrifice, for sacrificing his time and talking to us through this important conversation and this important question. I can't see
Thank you so
anybody
much.
appreciating. I can't see anybody
Thank you.
appreciating.
Thank you so much, Dr. Meshach. God bless you,
Yeah,
sir.
thank you.
Thank
Thank
you
you
so
very
much,
much.
sir.
Thank you.
Yeah. Thank you for thanking our guest speaker today. Yeah.
Thank you.
So thank you. I really appreciate. And thank you
Yeah.
everyone for
Bye-bye.
joining. Thank you for joining the call today. And next week we are getting to the end of this conversation. And as we are progressing, I'll be like, I didn't have this part into the conversation, to the series, but I think we will leave it at that for now. So next week we'll be having Michael Adikambi, who will be taking us through um let me see. Yeah, we have Michael Aderele who will be taking us through research writing, referencing, and plagiarizing. Hopefully, you'll be able to talk also into result and discussion. I believe so. That's part of research writing. So do not miss that as well. Join us next week and let's have some moment of learning and all of that. All right. Thank you once again, everyone. And thank you for waiting to this time. I know it's getting late in Nigeria right now and some other part of Africa or where you may be joining from. And see you again next Saturday. Till then, stay safe, stay healthy, and have a great evening.
Thank you so much.
Thank you.
Thank you so much, sir.